Hi everyone. Today I on behalf of RoboSM welcome you to an introductory session on navigation. So, what is navigation? It is the process of accurately ascertaining one's position and planning and following a route. So for example, I am at point A and I have to reach to point B. So the route which I would have to take and the planning related to it is included in navigation. So in robotics, we plan how a robot would move from point A to point B, considering the obstacles in the path, and that is navigation. Now, what are sensors? A sensor is a device that detects and responds to some type of input from the physical environment. So, for example, we want to measure the temperature in the surrounding, so we would use a temperature sensor. That is, it takes some input from the physical environment and we get it in the form of an output which we can read. Now we will look at sensors used in navigation. So here are some examples: ultrasonic sensor, radar, lidar, sonar, etc. Now what is an ultrasonic sensor? So an ultrasonic sensor is a sensor which works by emitting sound waves at a frequency too high for humans to hear, that is ultrasonic frequency. They then wait for the sound to be reflected back, calculating distance based on the time required. So for example, we know the speed of sound in water v, and we know that s is equal to v into t, that is distance is equal to speed into time, considering v to be constant. So from that formula, we know the time it has taken for the signal to come back, so we can calculate the distance. The distance we will obtain, we will divide that by 2 to get the distance between the sensor and the object from where the frequency has been reflected. Now for underwater, we use another sensor called sonar. So a sonar is a device for detecting and locating objects, especially underwater, by means of sound waves sent out to be reflected by objects. So it is based on the same principle that is used in the ultrasonic sensor, that is, we send the high frequency waves underwater and it is reflected by some object such as a submarine or maybe the surface of the ocean. So we can calculate the depth of the ocean or the depth under which there is an object such as a submarine from the ocean level or the sea level. It is used for detecting the presence of a vessel such as a submarine by the sound it emits. So it works on the principle of reflection of sound. Here we can see that the transducer sends ultrasonic pulse which is reflected by the bottom of the sea, and then it is detected by the detector. So we can calculate the distance from the surface of the sea to the bottom of the sea by dividing the distance we get from s is equal to v into t. Now we will look at kinematics of a robot. So for simple two-wheeled robot, we can get the state by three variables: its x coordinate, y coordinate, and theta, the angle with the x-axis. Now we get the vx, that is the velocity in the x direction, as v cos theta, and in the y direction as v sin theta, and our angular velocity omega is d theta by dt. Now we are here applying kinematics, that is we are only considering at the velocities and the position and not the force diagrams. We are not considering the forces acting on the body. So for a simple two-wheeled robot, with the two wheels having angular accelerations omega 1 and omega 2 and having a distance of 2l between them, the radius of either of the wheels being small r. The bot is actually rotating about an instantaneous center if v1 and v2 are different. Otherwise, it goes on in a straight line and the instantaneous center of rotation is at a distance of infinity. So, this mechanism of turning, where turning occurs due to the difference in velocities of the two wheels, is called a differential drive. So now we have the radii of the wheels. So the velocities of the center of the wheels are v1 is equal to r into omega 1, v2 is r omega 2, and the net velocity of the bot is v1 plus v2 by 2, that is r times omega 1 plus omega 2 by 2. So to summarize, here rho is the distance between the wheel having omega 2 and ICR. So we get omega is minus v2 by rho is equal to minus v2 minus v1 by 2l. And then we can get the omega of the bot as r omega 1 minus r omega 2 by 2l. So we put these values to get Vx is equal to V times cos theta, Vy is V times sin theta, and d theta by dt is equal to omega, that is this value, r omega 1 minus r omega 2 by 2l. So now we look at the dynamics of the bot. That is, now we will deal with the forces acting on the bot and we shall conserve the forces in the horizontal and vertical directions. So for the basic bot, moving on an inclination against a rolling resistance, if the net acceleration is a, that is the net force is ma, it faces a retardation in the form of rolling resistance r as well as mg sin alpha, where alpha is the angle between the inclination and the horizontal surface. So from here we can get the motor drive force F is equal to ma plus r plus mg sin alpha. So here a is equal to r alpha, where alpha is the angular acceleration of the wheel. So using this motor drive force F, we can calculate the torque required for the motion. So that was all for the introduction to navigation in robotics. Hope you will find it useful. Thank you.